right, folks, here we go. Video 2 of 3. Now we're going to solve by a different method. This is called the substitution method for solving the systems of equations. So it's going to use the substitution property of equality. All right, that's it. It's come up in proof so far this year. Again, reminding you what a system is here. In order for this to be a parallelogram, then we would have to find values that would make MJ equal to 26. That's our second equation that we have here. We earn a first equation, that I've written right here. We earn this for the fact that we're trying to make this a parallelogram. It has to be a parallelogram, and so that would mean values for x and y. That's going to make 4x plus y equal to 42, because remember, opposite sides of a parallelogram are going to have to be congruent to one another. Okay, so and if they're opposite sides of a quadrilateral congruent to one another, then the quadrilateral is a parallelogram. Two equations to deal with. I'm going to show you in these videos, a series of 3 ways to solve for what x and y have to be, and that involves solving a system of equations we have here. 2 equations that share the variables. All right, substitution method is perhaps a little bit easier, actually, than the equal values method, the one you saw before. Okay, so what substitution method is the key thing is we're going to get a variable, right? Could be x, could be y, get a variable by itself. Okay, get a variable by itself. That's what we're going to problem. Get a variable by itself and then substitute it into the other equation. Okay, because remember the substitution property. Okay, substitution property, if we remember back to section 1.4 from our geometry textbook, it says that equal things, right? Equal things can be substituted for one another into an equation or an inequality. Okay, so we've been dealing with that all year. Sometimes we get statements of equality in one part of a proof, for instance, and then we get another equation later, and we want to take like that one thing that appears in the equation later, and we want to replace it with something that it was equal to earlier in the proof, for instance. Okay, so we were doing the substitution property of equality within geometry as well. So that should sort of jog your memory about what you're going to have to do, right? What you may have had to do algebraically. Again, this should have been like kind of an 8th grade thing that we reviewed 9th grade. And again, it was in your fall final. If you are a 10th grader this year, you had a fall final last year. Solving using substitution should have been on it. But let's just go through it real quick, okay? Because the idea, this is super easy. Look, why don't we get y by itself again? We were dealing with y earlier. Well, how do I get y by itself? Subtraction property of equality. Let's take away those 4 x's. Let's get rid of them. Yoink, yoink, those go away. And then I get that y. This is the same exact thing we did earlier, right? You're like, Mr. Fortin, I've done this. Oh, there's going to be another step after this that's going to be a little bit different. Okay, so now I have y isolated. This is a little bit different. What did we do last time in the equal values method? Well, I solved for y again, set the 2 expressions equal to each other, solved. I'm not going to do that right now. I'm going to take what y is equal to, right, which is here. And note, I have y right here. Okay, y right here. So if I'm following the substitution property of equality, okay, substitution property, equal things can be substituted for one another into an equation or an inequality. So what is y equal to? Well, it's equivalent to 42 minus 4x. So I'm going to take that. Right? I might as well take that and droppity that in there, right? I might as well do that. So this is a way of rewriting this second equation so that y no longer appears in it, but an expression involving x does, because I had y isolated from earlier in this freaking problem, right? In this equation number 1. So we got this negative 2 times by 42 minus 4x. And that's going to equal 26. And check it out. Look at that. That's what you're going for there. That's why we couldn't solve this here. Couldn't solve this here because these had 2 variables in them. 2 variables in them here. Now this only has 1 variable because we replaced it here. And we're good to go. Let's go ahead and solve this by the substitution method. So I get 3x. Negative 2 times by 42 is negative 84. So you got to do some mental math. You can pull up your calculator. No, pull up Spotify. Pull up your calculator and get through this here. This is distribution here. You got to distribute a lot when you're doing substitution, but we got negative 2, right? Negative 2 went to that 42, that's negative 84, but negative 2 distributes to that negative 4x, and that's going to be negative 2 times negative 4 is positive 8. So that's going to become 8x here. That's going to equal 26. And now we can combine like terms, right? 3x plus 8x is 11x. I'm going kind of quickly because this should be pretty easy for you. If you are in geometry right now, solving an equation like this should be pretty easy for you. If not, you got to figure out ways to practice solving equations, right? Practice solving equations. So yes, should have plenty of this in Algebra 1, or just realizing we got bigger problems to deal with in geometry than this. That shouldn't have taken very long here. Adding 84 to each side, that shouldn't take very long, plus 26. You can maybe use your calculator real quick. Again, computation is not a big deal if you're not so sure about it, but 84 plus 26 is 110. And that's nice, right? That's nice. It's 110 because this is 11 here. What do we need to do to both sides to solve for x, right? Division property of equality. Let's do it. And x is going to equal 110 divided by 11. It goes into it 10 times. That's perfect. Look at that, 10 times. So what do we notice here about our answer using the substitution method compared to my last video? Well, solving via these methods is going to allow us to arrive at the same answer, the same conclusion. I'm just using properties of equality all along here. I use substitution property of equality to take something that y was equal to and replace y in the other equation. And then I do distributed property of multiplication over addition right here, or subtraction. And then I combine like terms, that's just addition right there. And then I did addition property of equality, adding 84 to both sides, division property of equality. Anyways, I've solved it through legally agreed axioms within algebra within our maths here, and I ended up with the same answer. Just like the equal values method, those were all legal axioms that were used, or like it's kind of like postulates for algebra. But anyways, we got what we want here. Okay, second part of the problem is going to be the same thing, right? Same thing that we did before, and that is going to be, right, take equation number 1, okay, 4x plus y equals 42, right? Take that equation number 1 and replace the solution we had for x from equation number 2. We're going to put that, boom, right there, and we're going to use that to solve for y. Okay, so you already did this in the last one, so I probably don't need to film this again, but right, regardless of how you're solving using one of these methods for solving a system, you're going to have to plug in to the other equation to solve for the other variable. So I'm just doing the same exact thing. I said how to do this. If this is the method that I chose the first time, substitution. 4 times 10 is 40, plus y equals 42. And yeah, this is just the same thing we did before, y would equal 2, and we're good to go. All right, substitution method done there. So just think about the differences here. I had to, first step, isolate a variable by itself, get a variable by itself. And the second step was take whatever that variable was equal to and plug it on in for that variable to the other equation. So I put 42 minus 4x in here for y, right? For y that we had here. So I still had -2, so I need to distribute. So that was a little messy. Okay, went solved for the variable, plugged it back into the other equation for what that variable represented as a numerical value. Solve for the numerical value of the other variable to find the common solution. Okay, the common solution here. So our answer is x equals 10 and y equals 2, which is the same thing that we had in video number 1 with the equal values method. Email me if you have any questions. Perhaps try some Khan Academy to get some extra practice with this method, and I will be in touch soon. See you guys. Bye.